We will look at a composition of two functions at a number in this video. So let's look at our two functions. Let's say f of x is x squared minus 1, and g of x is the square root of x plus 40. Let's first do the composition of f composed, that little circle in between, that is not multiplication, that is a composition symbol, composed of g evaluated at 9. So what does that mean? Well, that means that, first of all, that number in the parentheses, that means x equals 9. This is a composition symbol. This can be rewritten in a different format that sometimes is easier to understand. F, then a big parenthesis, composed of G evaluated at 9. So that's the way it can also be written. This is two notations that are equal to each other. They're used interchangeably, so you should be able to read both of these notations. So what do we do in this case? This is when x is replaced with a number. Well, the easiest thing to do is to work inside out. Let's try that. Let's go ahead and start with evaluating g at 9. So g at 9, that just means take the function g and replace the x with the 9. So square root 9 instead of x plus 40. So which is the square root of 49, which is 7. Now that you have figured out this number, you're going to plug that in to the function f on the outside. So the next thing you're going to do is say f evaluated at 7. So function f is x squared, so 7 squared minus 1. 7 squared is 49 minus 1, that's 48. This is the answer to that problem. If we wanted to write it the correct way, we would have to say f composed of g evaluated at 9 equals 48. The 7 that we found was just an intermediate answer, and it does not get boxed in. Now let's go ahead and do the same thing, but just switch the functions around. So this time, instead of f composed of g at 9, we're going to do g composed of f. We're going to do a different number at 5. So again, this is the same thing as g composed of f, which is evaluated at 5. So you work inside out. So first, you're going to evaluate f at 5. F evaluated at 5. Function f is x squared minus 1. Replace the x with a 5. 5 squared minus 1. That is 25 minus 1, 24. Do not box it in. This is your intermediate result. Then take that 24 and plug it into the function g instead of x. The function g is the square root of x gets replaced with the 24 plus 40. So that's the square root of 64, which is 8. This is the answer to that problem. We also have composition of two functions without replacing x with a number. So let me clear the screen and we'll look at those compositions. So we're still doing composition of two functions. We'll pick different functions for this one. Let's say f of x equals 3x squared plus 1, and g of x this time we'll do 2x minus 5. And this time, instead of replacing x with a number, we're going to stay with the x. We're still doing composition of functions. And we'll do f composed of g first, evaluated at x. So this is the same as this notation, f composed of g of x. what does this mean? This means that you're going to take the whole function g, which is this right here, and you're going to plug it in to the x in the function f. So take the whole function g, the inside function, and plug it into the x on the function f, which is outside. So this is going to be 3. Then in parentheses, because g has 2 terms, in parentheses, 2x minus 5. So this replaces the x in function f. You still have to square it, and then plus 1. Now then you have to simplify it. You do have to remember that 2x minus 5 squared is the same as 2x minus 5 times 2x minus 5 plus 1. Okay, now we're going to have to FOIL the 2 parentheses. We're going to have to distribute the 3, and then at the end, we're going to have to do like terms. So let's go ahead and try that. So 3 is still there. 2x times 2x, that's 4x squared. 2x times negative 5, that's negative 10x. Negative 5 times 2x, that's negative 10x. Negative 5 times negative 5 is positive 25, close parentheses, plus 1 is still there. Okay, you can do it a couple times. You can go ahead and combine the like terms inside the parentheses. That's how I like to do it. So let's go ahead and do that. We'll go ahead and combine the like terms so it doesn't drag on. 3, 4x squared minus 20x plus 25 plus 1. Now I'm going to go ahead and distribute the 3 on the outside of the parenthesis. So that means 3 times 4, that is 12x squared. 3 times negative 20, negative 60x. 3 times 25, positive 75 plus 1. Now the only like terms we have is 75 plus 1. So we'll go ahead and rewrite it one more time. 12x squared minus 60x plus 76. And that is going to be the final answer for the composition of f with g evaluated at x. All right, we'll go ahead and do it again, but this time we're going to do the composition of g with f, still evaluated at x. So let's go ahead and plug in the function. So this time, let me erase this, because this time we are going to take the whole function f and we're going to plug it in for x in the function g. So the inside function gets plugged into the outside function. And this can be written like this with function f on the inside. So it is a little bit easier this way. So 2 multiplied by 3x squared plus 1. And then all you, oh, minus 5. I lost the minus 5. And then all you have to do is distribute the 2 on the front and then do like terms if you have any. So 2 times 3, this is 6x squared. 2 times 1 plus 2 minus 5. And then plus 2 minus 5 are like terms, so let's go ahead and combine them. Plus 2 minus 5, that's negative 3. And that is the answer for the composition of the function g with the function f. Now, real quick, let's notice that the composition of f with g is not the same as the composition with g and f. So if you switch the 2 functions, the composition of 2 functions is not commutative. If you switch places, f composed of g and g composed of f, they're not the same. In general, there's some exceptions, but really we don't discuss those until higher level math classes.